Madam, start with madam. Madam, start with madam classes.
Sir, shall I begin the class, sir?
Begin, madam. Start, madam.
Okay, thank you. Good evening, dear students. Welcome to TREI's webinar classes. So in the last session, we have learned the introduction of solid states. Now we are going to see the crystal arrangements. So you know what is a crystal lattice? So a regular repeating pattern of the constant particles in 3 dimensions is said to be crystal lattice. So what is a crystal lattice, Nana? A regular repeating pattern of the constant particles in the 3 directions, in the 3 dimensions is said to be crystal lattice. You can see here, this is a crystal lattice. And these points are said to be lattice points where the constant particles are arranged. So when you join this constant particles with a straight line, you will get a geometrical shape. Okay. So the smallest portion of the crystal lattice is called as unit cell. This is repeated in all the three directions. The unit cell is repeated in all the three dimensions. So what is a unit cell, Nana? Unit cell is the smallest portion of the crystal lattice. It is repeated in different directions. So all together, see here, this is one kind of arrangement. So like these arrangements, like this possible variations, nearly 14 possible variations will be there. Here you can see only one type of possible variations of crystal lattice. Like this, you have the 14 types of arrangements. So those 14 possible variations are called as Bravier's lattices. So what are Bravier's lattice? So these crystal lattices are arranged in 14 types. So those 14 lattices are said to be Bravier's lattices. So you can see so here you can see there are 14 Bravier's lattices. So from this chart, you may expect one question. So let us see here. So before going to that, let us see the characteristics of the unit cell. So these are the axial lengths. So you can see the axial lengths, you can call them as edge lengths or edge distances or axial distances. They are one another the same. So here the axial lengths are A, B and the C. You can see here very clearly. This is the axial length A, axial length B and axial length C. So these are the edge distances or axial lengths of the unit cell. Okay, and the angles, axial angles are alpha, beta and gamma. So there are 6 parameters for describing a unit cell. So what are the 6 parameters that describe the unit cell are A, axial lengths A, B, C and axial angles alpha, beta and gamma. Okay, so keep it in mind, Nana. Unit cell. What is a unit cell? Unit cell is the smallest repeating pattern of a crystal lattice, which are characterized by axial lengths A, B, C and axial angles alpha, beta and gamma. So these are the 14 Bravier's lattices which you can see here. Okay, so we'll come later for describing these Bravier's lattices. So let us go to the most important thing, this chart. You may expect one question from this chart. So, you know, there are 7 types of crystal systems. So based on the geometry, we can see that the crystal systems are broadly classified into 7 types. They are cubic crystal system, tetragonal crystal system, orthorhombic crystal system, monoclinic, triclinic, trigonal and hexagonal crystal system. So how many, you may get question in some of the competitive exams, they have given how many crystal systems are there. So answer is 7. Don't write it as 14. Bravier's lattices are 14, but the crystal systems are 7. Keep it in mind, Nana. How many Bravier's lattices are there? 14. But crystal systems are 7. So how they are classified? Let us see here. You have to remember all the axial lengths and axial angles, as well as how many possible variations are there in this particular crystal system. Okay, so I gave a trick to you all. I'm going to give a trick to you all so that you can easily remember it. So let us see the trick. What is that? So I made these 7 crystal systems. See how many 7 crystal systems are there? There are 7 crystal systems. So I classified these 7 crystal systems into 3 groups. Okay, so let us see what are those 3 groups. So first 2 is one system. I hope everyone is noting it down. So see here, the first crystal system, this is the first group, and this is the second group, and this is the third group. So what are the crystal system present in first group? Cubic crystal system and trigonal system. So here you can see the axial distance. A is equal to B is equal to C. It is a symmetrical system. All the axial distances are equal. Okay. And in trigonal also you can see A is equal to B is equal to C. So in the first type, in the first group, What are the crystal system I have selected? Cubic and trigonal, in which the axial distance A is equal to B is equal to C. Okay. And coming to second group, that is tetrahedral and hexagonal group. Tetrahedral and hexagonal group. In tetrahedral, all the axial distances are not symmetrical. You can see they are unsymmetrical. A is equal to B and B is not equal to C. In the second group, A is equal to B, B is not equal to C. That is, you can see in hexagonal also, A is equal to B, B is not equal to C. In first group, what is the axial distance? A is equal to B is equal to C. But in second group, you can say, write it down, A is equal to B, B is not equal to C. And coming to third group, so there are IC families, you can see, they are orthorhombic, monoclinic and triclinic. So, okay. So the third group contains how many crystal systems, Nana? 3. They are orthorhombic crystal system, monoclinic system and triclinic system. Here, all the axial distances are unequal. That is, A is not equal to B, B is not equal to C. In monoclinic also, A is not equal to B is not equal to C. And triclinic, A is not equal to B is not equal to C. Okay, understood, Nana? So I classified these crystal systems into 3 groups. They are one in first group, cubic and trigonal, and in second group, tetrahedral and hexagonal, and in third group, orthorhombic, monoclinic and triclinic. So in first group, all the axial distance are equal. And in second group, A is equal to B, it is not equal to C. And coming to third group, A is not equal to B is not equal to C. Okay, here you can see the symbols. Here all are equal. Here B is not equal to C, and here all the axial distances are unequal. Okay, coming to axial angles. So coming to axial angles, what is the first crystal system in the first group? Cubic. So here, first group alpha is equal to beta is equal to gamma is equal to 90. All the angles equal to 90 in the first member of the first group. And coming to the first member of the second group. What is the first member of the second group? Tetrahedral. So it is also equal. See here. Alpha is equal to beta is equal to gamma is equal to 90. Coming to what is the first member of the third group? Orthorhombic. In orthorhombic also, alpha is equal to beta is equal to gamma, which is equal to 90. So once again, the first group, in the first member of the group, first crystal system, cubic, tetrahedral and orthorhombic, have all the angles equal, and that is equal to 90. Nana, based on this chart, we are going to see so many questions. So please note it down, all of you. Okay. So coming to the second one, trigonal. Here, in trigonal crystal system, alpha is equal to beta is equal to gamma, but they are not equal to 90. But it is not equal to 90. Understood? In trigonal, all the angles are equal, but those angles are unequal to 90. Not equal to 90, but it is less than 120. All of you understood, Nana? In trigonal, all the angles are equal. Alpha is equal to beta is equal to gamma, but it is not equal to 90. The angle is less than 120. Okay. And tetragonal, we have learned. Okay. Coming to hexagonal. In hexagonal, alpha is equal to beta. It is equal to 90. And gamma is equal to 120. Okay. In hexagonal, what is hexagonal? Alpha is equal to beta is equal to 90 and gamma is equal to 120. Orthorhombic is also completed. Now coming to monoclinics. What is monoclinic? Here in tetragonal, in hexagonal, we know that alpha is equal to beta is equal to 90. But here in monoclinic, alpha is equal to gamma. It is equal to 90. Beta is not equal to 90. And coming to triclinic, all the angles are unsymmetrical. They are not equal to 90. So in triclinic, the name itself, clinic means what? Unequal. Tri means all the three. So in triclinic, it is very easy to remember triclinic, that all the axial distances are unequal and all the axial angles are unequal. Coming to first member, all the axial distance are equal and all the axial angles are equal to 90. Okay, all of you understood? So this is the small trick. I hope everyone understood it. Once again, I'm repeating, Nana. Please look it. So all the 7 crystal systems I made into 3 groups. The first group contains what are the crystal systems? Cubic crystal system and trigonal crystal system. In the second crystal system, what are the crystal systems? Tetrahedral and hexagonal crystal system. And in the third one, that is orthorhombic, monoclinic and triclinic are placed. So in cubic and trigonal, all the axial angles are equal. You can see A is equal to B is equal to C, A is equal to B is equal to C. Coming to tetrahedral, A is equal to B, it is not equal to C. See here, in first group, all are same. Coming to in second group, A is equal to B is not equal to C, A is equal to B is not equal to C. And coming to third group, all the axial distance are unequal. A is not equal to B is not equal to C. Okay, clear? Coming to axial angles. In axial angles, all the first crystal systems in 3 groups. What are the first crystal systems? Cubic, tetrahedral and orthorhombic. What are the first systems? Cubic crystal system, tetrahedral system and orthorhombic. In all these 3 crystal systems, alpha is equal to beta is equal to gamma. It is equal to 90. Okay, see here you can tetrahedral. Alpha is equal to beta is equal to gamma is equal to 90. And in orthorhombic, alpha is equal to beta is equal to gamma. It is equal to 90. Coming to trigonal. In trigonal, this is the second one in first group. Tri means 3. Okay, they are all the angles are equal, but these angles are not equal to 90. Here alpha is equal to beta is equal to gamma, but it is not equal to 90. It is less than 120. It is less than 120. Once this question is asked. Okay, in trigonal, all the sides are equal and all the angles are equal, but it is not equal to 90. Coming to hexagonal, alpha is equal to beta, it is equal to 90 and gamma is equal to 120. Okay. In hexagonal, alpha is equal to beta is equal to 90 and gamma is equal to 120. So orthorhombic, as you all know, this is the first member of the third group, which is equal to 90 degrees. Coming to monoclinic, alpha is equal to gamma is equal to 90, but beta is not equal to 90. Okay. And triclinic, it is very clear that alpha is not equal to beta, beta is not equal to gamma, and which is not equal to 90. Okay. So let us see the possible variations. So what is possible variations? Just now we said that there are 14 possible variations in Bravais lattice. So they are in cubic system. Cubic means what, Nana? 3. So just imagine that it is cube. So 3. So how many possible variations are there? 3. And coming to tetrahedral, for all the last members, what is the last member here in the group? Trigonal. And what is the last number? Hexagonal. And what is the last one? Triclinic. So all these have one possible variation. So this is one possible variation. Hexagonal has one possible variation and triclinic has one possible variation. And the maximum number of possible variations are for orthorhombic. So you can see that in orthorhombic there are 4 possible variations. Once you can see this figure. From this figure, Nana, see these are 14 Bravais lattices. So in cubic systems, there are 3 cubic systems. So you can see that there are 3 cubic systems. So Nana, just keep it in mind that simple cubic system, simple primitive unit cell is common in all the crystal systems. Simple cubic system is common to all the geometrical crystal systems. So you can see here in cubic system, in cubic system there are three possible variations. They are simple cubic system, face centered FCC. What do you mean by FCC, Nana? Face centered cubic crystal system or face centered cubic cell. You can also call them as FCC. FCC. If anyone say what is FCC means, what you say? Face centered cubic cell, unit cell. What is BCC means? Body centered cubic cell. Okay, what is simple cell? Okay, this is called as a simple cell. In simple cubic, in cubic unit cells, there are three possible variations. They are simple cubic cell, face-centered cubic cell, and body-centered cubic cell. In tetragonal, there are two possible variations. They are simple tetragonal variation and body-centered. Nana, this question is also asked previously. Okay, so remind it. In cubic crystal systems, how many possible variations are there? Three. What are those three? Simple cubic, face-centered, and body-centered. Coming to tetragonal, how many possible variations you can see? Two. What are those two? Simple is common, I said you. Simple tetragonal and body-centered. In tetragonal, only two possible variations are there. They are simple tetragonal and body-centered tetragonal. Body-centered tetragonal. You can see body-centered tetragonal. Okay. Coming to hexagonal, only one primitive unit cell is present. That is simple unit cell is present in hexagonal. Okay. And here for rhombohedral also, only simple unit cell for hexagonal and rhombohedral. Trigonal is also called as rhombohedral, Nana. Trigonal crystal system is also called as rhombohedral. Rhombohedral, hexagonal, and triclinic have only one primitive possible variation. Okay. And one question is asked like this: how many possible variations? What are the maximum number of possible variations for orthorhombic? You can see how many variations are there. All the four types of possible variations. They are simple orthorhombic, body-centered orthorhombic, base-centered. This is end-centered orthorhombic and face-centered. All kinds of possible variations are seen in orthorhombic. Okay. So in orthorhombic, how many types are there, Nana? Simple orthorhombic, body-centered orthorhombic, base-centered orthorhombic, and face-centered orthorhombic crystal systems are there. Okay. And coming to monoclinic, two types. In monoclinic, how many possible variations are there? Two. They are simple monoclinic and base-centered monoclinic. So once again repeating, just please look at it. So how many Bravais lattices are there? There are 14 possible variations. 14 Bravais lattices are there. Okay. When a crystal is arranged, how many possible variations are there? 14. So all these are 14 possible variations. So the maximum number are seen in orthorhombic crystal systems. Okay. And the minimum, only one lattice system is seen in hexagonal, rhombohedral, trigonal, hexagonal, trigonal, and triclinic. These are the three crystal systems which have only one possible variation. Okay. So I'm going to ask you some questions based on this. Once look at it. Cubic crystal systems has three variations, that is simple cubic, face-centered cubic, and body-centered cubic. In tetragonal, two variations are there. They are simple tetragonal and body-centered tetragonal. In hexagonal, only one. And in orthorhombic, four crystal systems are there. They are simple orthorhombic, body-centered orthorhombic, base-centered, and face-centered. And coming to monoclinic, two variations are there. They are simple monoclinic and end-centered or base-centered monoclinic crystal systems are there. Okay. So let us have some questions on the topic. So the first one is the number of parameters that define a unit cell. So you know what is a unit cell? Just now we have learned. So unit cell is the smallest portion of the crystal lattice. So what are the parameters? The parameters are 3 axial angles and 3 axial distance. A, B, C are the axial distances and alpha, beta, gamma are axial lengths. So altogether, how many parameters we are having? We are having 6 parameters. So there are 6 parameters to define a unit cell. They are alpha, beta, gamma, A, B, C. Okay. Now coming to the second question, which constant particles are present only at the corners of the unit cell? So this question I did not say, but okay, you know it very well. So which constant particles are present only at the corners? So you can see here, this is a crystal system. See here, all the particles are present only at the corner. See here, this is the system in which only they are present at the corner. So that unit cell is called as what, Nana? Simple unit cell. Or you can also call it as primitive unit cell. Okay, so in primitive unit cell, only the particles are present at the corners. Okay, so we did not discuss about these. Let us go for the next question. So here the third question is, in monoclinic unit cell, the relation of sides and angles are respectively. I hope you all do it. I'm going to give you a minute time. Please check the table and say me. Monoclinic. Just now I said it is an example of third group. Clinic means what? All the sides are unequal. All the sides are unequal. And in angles, alpha and gamma are equal to 90 and beta is not equal to 90. Okay. I hope you got the answer. In a monoclinic unit cell, see here in monoclinic unit cell, the sides A is not equal to B is not equal to C, and the axial angles alpha is equal to gamma is equal to 90, but beta is not equal to 90. So you may expect a question from this, Nana. Okay, so please go through the table. Now coming here, in which of the following crystal systems all the angles are not equal to 90? All the angles are not in cubic, you know very well that all the angles and all the sides are equal. In trigonal, this is the second of the group. Here all the distances A is equal to B is equal to C. But angles are also equal, but they are not equal to 90. So the answer is what, Nana? Trigonal. Just you can see in the table. In trigonal, all the axial distances are equal and axial angles are also equal, but that angles are not equal to 90. Okay. Now coming to next, how many Bravais lattices are present in cubic crystal system? So all these questions were asked previously in competitive exams, Nana. Okay, so I hope everyone will do it. So you know how many Bravais lattices are present in cubic crystal system. So just now we discussed, this is cubic crystal systems. Okay, how many cubic crystal systems are there? There are simple cubic system, face-centered cubic system, and body-centered cubic. So total 3 cubic systems are present. Okay, now coming to, so answer is 1, 2, 3 or 4. So the answer is 3, Nana. Simple cubic system, body-centered cubic system, and body-centered and face-centered cubic system. Coming to end-centered lattice, the other name of end center is base center, or you can also call them end base center. Okay, end-centered lattices can be found in which of the following? In monoclinic, yes. In monoclinic, how many lattices we have seen? One is simple monoclinic, and the other one is end-centered monoclinic. Okay, and all these remaining have only one lattices now. That is, hexagonal has only one simple unit lattice, rhombohedral has only one system, and triclinic also has one crystal system. Okay, coming to the next question, the crystal system that shows maximum variations to produce Bravais lattices. So you know cubic has three possible variations. Tetragonal has 2 possible variations. Orthorhombic has maximum, that is 4 possible variations. That is, they have simple, end-centered, body-centered, and face-centered. And triclinic has only 1 possible variation. So, we have learned unit cells very well. So, based on the arrangement of the particles, Nana, so based on the arrangement, unit cells are of 2 types. They are primitive unit cell. This is the basic unit cell present in all types of variations. Okay. Next one is centered unit cell. In primitive unit cell, the particles are present only at the corners of the unit cell. So see here, this is the basic. Primitive unit cell is present in all types of cells. But if you draw a crystal system, so keep it in mind, you have to note you have to place all the corners. Okay. So primitive system where the particles are present only at the corners. You can see these are the corners of the cube or any crystal unit cell. See here, these are said to be corners. How many corner points are there? Crystal points. This is 1, 2, 3, 4, 5, 6, 7, 8. So in a primitive unit cell, the particles are present only at the corners and they are 8 in number. Coming to centered unit cell, the particles are present at the corners. See here, they are present at the corners and as well as other positions. So the name itself, see Nana, face means how many faces are there? There are 6 faces. Everyone know face centered. So centered unit cell. How many centered unit cells are there? First one is face centered unit cell, body centered unit cell, and end centered unit cell. Okay. In simple unit cell, the particles are present only at the corner. In face centered, the name itself, please remind it, face centered, where the particles are present along with the corners, the particles are present at the phases. How many phases are there? 6 phases are there in a unit system. Okay, how many phases will be there in a unit system? 1, 2, 3, 4, 5, and 6. So total 6 phases are there in a face centered unit cell. Okay, in body centered, coming to body centered, just the name itself says body centered means what? The particle is present inside the body. Okay, only one particle is present. Only one particle is present inside the body. So that's why it is said to be body centered crystal system. And the next one is base centered or end center. End center means what? Above and below the phases. In face centered, you have seen the particles are present on all the 6 phases of the unit cell. But in end centered, only the particles are present above and below the plate. Okay. So how many unit cells are there? There are 2 types, primitive unit cell and centered unit cell. In primitive unit cell, the cells are present at the corners. It is common to all the type of geometries. Okay. And coming to face centered, face means how many phases are there? Nana, if you know this, all the problems are based on this. If you understand this but correctly, you can do all the problem based on solid state. Okay, so I'm emphasizing more on this. Okay, so coming here in face centered, how many phases are there? 6 phases are there. Coming to body centered, only one particle is present at in the middle of the unit cell. And coming to end center, one is above the cube and the other one is below the unit cell. So this is, you can see primitive unit cell, only the particles are present at the corners of the unit cell. And body centered, here they are present in the middle of the unit cell and in phases, all 6 phases, the particles are present at the 6 phases, and in end face centered, they are present above and below the plane. Okay. Now coming here, how many atoms? The question arises, how many atoms are present per unit cell in cubic lattices? In simple cubic cell, only one atom is present. Let us see here. Body centered 2 atoms, face centered 4 atoms, and end centered 2 atoms. How they are, let us see. Now coming to simple cubic system. So here, how many particles you can see? 8 particles. 1, 2, 3, 4, 5, 6, 7, and 8. So keep it in mind that a unit cell is the repeating portion, repeating parts in all the directions. So here, this constant particle contribution is 1 by 8. For example, if I draw a yes, Nana, if I draw, think this is an atom. If I cut this atom into 8 equal parts, if I cut this atom into 8 equal parts, you get one part. Sorry. If I cut, okay, think this is an atom or a molecule. If I cut this atom into 8 equal parts, 1 by 8 part is present in this unit cell. Okay, understood? So if you just by seeing this, you are imagining that the total particle is present in this unit cell. No, only it's 1 by 8 part. If I cut this atom into 8 parts, only one part is shared here, and remaining all 7 by 8 parts are linked with the other unit cells in the crystal lattice system. Okay, understood? So its contribution is only 8th part. So I hope you all understood. Only 1 by 8th part is linked with this unit cell. Remaining 7 by 7 parts are linked with the other unit cells in the crystal lattice. So the contribution of this particle in this unit cell is 1 by 8. And coming to this is also 1 by 8. This is 1 by 8. This is 1 by 8. 1 by 8. So total, how many atoms, how many corners are there? 8 corners. And each contribution is 1 by 8. Okay, understood all of you? Here, only 1 by 8 part of the atom is shared in this unit cell, remaining is shared with the other unit cell. So total 8 into 1 by 8, total contribution will be 1 atom. Okay. Now coming to body centered. So I said that it is a common, corners are common in every cubic, in every centered cell, in any unit cell. This is the common. So its contribution is 1. The particles, it is equal to 1 atom, and one more atom is present at the center. You can see here. One total atom is present in the center, body center. Okay, so total contribution, this is total 1 atom, and here total 1 atom. So the total number of atoms present in body center is 2. If anyone asks you, how many number of atoms are present in body center? So body means the atom is present at the center. Okay, and one common thing is they are present corners. So 1 plus 1, it is 2 atoms. And coming to face centered. So I just said that along with the corners, the atoms or the particles are present at the corner. So this is one corner. You can see half of the atom is present now. Half of the particle is present. You can see here very clearly. Only half of the atom is present here, and remaining half is shared with the other unit cell. Okay. Here one of the half of the atom is present, and remaining half is shared with the other unit cell. So how many phases are there? First phase, second phase, third phase, and back fourth phase. Here imagine fifth and down 6 phases. So total 6 phases are there. Okay, total how many phases? 6 phases. And each contribution how much? Only half of the cell. So each contribution is half. So 6 into half, 3 cells, 3 atoms are there, and here corners 1 atom. So 1 plus 3 total 4 atoms are there. In face centered cell, how many atoms are present? 1 from all the corners and 6 faces. So half in all the 6 faces, that counts 3. So 1 plus 3, it is equal to 4 atoms. Now coming to end centered. So end centered, I said all the atoms have 8 corners, and the remaining is 1 above and 1 below. If they are present in the corner, in middle of the phase, in 2 phases, so its contribution is half. So here half and here half. Total 1 atom. Okay, and here total 8 corners, 1 atom, and 2 faces, 1 atom. So total 2 atoms are contribution of the end phase centered is 2.
Madam, conclude cheyara.
Okay, sir. Okay. So once all of you please look at it, Nana. So in simple cubic system, cubic cell, how many atoms are present? Only 1 atom is present. And in body centered, 2 atoms. Face centered, 4 atoms. Body face centered, 2 atoms. So tomorrow we'll discuss some of the questions based on the unit cell. Okay. Thank you. Have a great day, all of you. Okay. Thank you, sir.